Hello everybody, welcome to Guidancee education channel. We will see the topic that is discussed in this video. We are continuing class 11 physics thermodynamics. Our topic is molar specific heat capacity of gases. We will see two relations. Molar specific heat capacity at constant pressure for a gas is greater than molar specific heat capacity of gases at constant volume, that is Cp is greater than Cv. We will also derive the equation Cp minus Cv is equal to R. This is Mayer's relation. This video will be a bit long, but this topic is very important, so watch the video completely without skipping. And if you think the video is useful, do like the video, share the video with your friends who may also be benefited, and also leave your feedbacks as comments in the comment box. If you're watching the video without subscribing my channel, do subscribe it now, which is totally free. And also press the bell button and all button so that you get intimated as soon as new videos are posted. Thank you very much. Come, let us see the. Before we start with molar specific heat capacity of gases, we will just see specific heat capacity of gases. As you know, specific heat capacity is the quantity of heat required to raise the temperature of unit mass of gas through 1 K. Solids, liquids and gases behave differently when subject to heat. When solids and liquids are heated, their pressure and volume do not change. So it is easier to calculate specific heat capacity in the case of solids and liquids, but not so in the case of gases. When gases are subject to heat, their volume and pressure change. Then, how can we study the effect of heat on gas? There is a problem. So, in order to overcome this problem, it is studied in two different ways. In one method, the pressure is kept constant and heat is supplied and the specific heat capacity is determined. In the second method, volume is kept constant and heat is supplied and then specific heat capacity is determined. Now, specific heat capacity determined at constant pressure is called specific heat capacity at constant pressure. Specific heat capacity determined at constant volume is called specific heat capacity at constant volume. So gases have two specific heats, that is specific heat capacity at constant pressure and specific heat capacity at constant volume. In both cases anyway, the unit is the same. Unit is joules per kilogram per K, because we have considered the mass here. But when we talk about molar specific heat capacity, we have to consider the mass in moles. Okay, we will see that. Now let us see molar specific heat capacity of gases. The symbol is capital C. We have said that gases have two specific heat capacities. So there are two types of molar specific heat capacity. Whatever may be the type, the unit is joule per mole per K. MOL is the symbol for mole. Okay. First type is molar specific heat capacity at constant pressure, and it is represented by the symbol Cp. What is the definition? It is the quantity of heat required to raise the temperature of 1 mole of the substance through 1 K at constant pressure. What is the other type? Molar specific heat capacity at constant volume. The symbol is Cv. So it is very simple. The definition is very simple. It is the quantity of heat required to raise the temperature of 1 mole of the substance through 1 K at constant volume. I hope you understand this. How is Cp related to Cv? Let us proceed. In order to find the relation between Cp and Cv, we will recall the thermodynamic equation. Delta Q is equal to delta U plus P delta V. What is P delta V? We know work done during expansion of a gas is P delta V. Now let us see one case. When a gas is heated at constant volume, that is constant volume means delta V is equal to 0. Then P delta V becomes 0. So no work is done. Work done is equal to 0. This portion of the equation becomes equal to 0. So all heat that is supplied is used for increasing internal energy. Heat is not at all lost in the form of work. So when specific heat capacity is determined at constant volume, all the heat supplied is used for increasing internal energy, that is increasing the temperature. So this is the case for Cv. What happens when a gas is heated at constant pressure? At constant pressure means delta V is greater than 0. Therefore, some amount of heat is used to increase internal energy U, and part of the heat is used to do work. So all heat is not available for increasing the internal energy. Increasing the internal energy means increasing temperature. So at constant pressure, more heat is required to raise the temperature of the substance. So naturally, the specific heat capacity of a gas determined at constant pressure will have a greater value than the value obtained for the same gas when the specific heat capacity is determined at constant volume. So we get the relation Cp is greater than Cv. This is one relation between Cp and Cv. We will see one more relation, that is Mayer's relation. It is a derivation and it is a favorite question for examiners. Mayer's relation says that Cp minus Cv is equal to R. R is universal gas constant. Let us see the derivation. We know delta Q is equal to delta U plus P delta V. Thermodynamic equation. If we divide both sides by delta T, we will get delta Q by delta T is equal to delta U by delta T plus P delta V. That is delta V divided by delta T. What is delta Q by delta T? At constant pressure, here pressure is constant, volume alone is changing. So that becomes delta Q by delta P at constant pressure is equal to molar specific heat capacity at constant pressure, that is Cp. You may recall the definition. We know the ideal gas equation for 1 mole of gas is equal to Pv is equal to RT. So P delta V is equal to R delta T. P delta V by delta T is equal to R, the universal gas constant. Let it be. For convenience, let us number this equation. Equation 1. Let us mark this equation as 2 and this equation as 3. Substituting equation 2 and equation 3 in equation 1, we get this quantity becomes Cp. This quantity is used as such and this quantity becomes R. So we get Cp is equal to delta U by delta T at constant pressure plus R. I hope I am clear. When volume is constant, delta V is equal to 0, then P delta V in the thermodynamic equation becomes 0. That is, no work is done. Then delta Q is equal to delta U because P delta V becomes 0. Now, dividing both sides by delta T, we get delta Q by delta T at constant volume, because we have kept the volume constant, is equal to delta U divided by delta T at constant volume. How did we get this? Let me repeat. We have divided this equation by delta T. Both sides are divided by the same quantity. So the equation does not change. So the values do not change. But we know delta Q by delta T at constant volume is molar specific heat capacity at constant volume. Compare this with this equation, delta Q by delta T at constant pressure is Cp. Similarly, delta Q by delta T at constant volume is Cv. Let us mark this one as equation 4 and this one as equation 5 and this one as equation 6. So we can substitute this equation 6 in equation 5. How does the equation change? Cv is equal to delta Q by delta T at constant volume is equal to delta U by delta T at constant volume. Equation 5 has changed here. Okay. Now, delta U by delta T at constant volume is equal to delta U by delta T at constant pressure equal to Cv because U is a state function. So whether heat is supplied at constant pressure or at constant volume, state function U is not affected. So delta U by delta T at constant volume is the same as delta U by delta T at constant pressure. Delta U by delta T at constant volume is equal to Cv. Since delta U by delta T at constant volume is the same as delta U by delta T at constant pressure, we can equate delta U by delta T at constant pressure is equal to Cv. Let us mark this equation as 7. Substituting equation 7 in equation 4, Cp is equal to Cv plus R because Cv is equal to delta U by delta T at constant pressure, this quantity. I hope it is clear. Earlier we got the expression or relation Cp is greater than Cv. Now we have Cp is equal to Cv plus R. From this we get Mayer's relation, that is Cp minus Cv is equal to R, the universal gas constant. We have simply shifted this Cv to the left hand side. This is Mayer's relation. Now, if we are considering unit mass, not mole, unit mass, then Mayer's relation can be written as Cp minus Cv is equal to R. We use small letters. Capital R is universal gas constant for 1 mole. Here, small r is universal gas constant for unit mass. Small letter Cp and Cv are specific heat capacities of the gas for unit mass. I hope you notice the difference. So, Mayer's relation can be written for molar specific heat capacity as well as for ordinary specific heat capacity. I hope this video was of great use to you. If you think it is useful, do like the video, share the video with your friends, and also leave your feedbacks as comments in the comment box below. Please subscribe my channel and support me if you have not yet subscribed it. And also press the bell button and all button for notification of more such new videos. Thank you very much. Now we will meet in the next video with another important topic like this. Till then, bye. Take care.